Good morning, everyone. Welcome to today's webinar. We're happy to have you. My name is Dr. Beth Stokes. I'm with Mississippi State University and a member of the Direfuse team. I'm going to start sharing my screen. Here we go. And welcome all of you to today's webinar. Our presenter today, let me do a little bit of housekeeping really quick. We do have the webinar series still ongoing. So please continue to register and check back for future events with those. The website and the QR code should be up on your screen at the moment. Those are going to continue to be available for the upcoming months. And our archived webinars are available on those pages. We also have upcoming workshops. Please register for the Mississippi workshop coming up next week. If you are able to attend and would like to attend, we're going to be hosting that here at Mississippi State University on the 29th of June. Tentatively, the Louisiana workshop is being rescheduled for the 26th of September. And our workshop at Texas A&M will be held on the 17th of August this fall. The registration link and QR code are there on your screen, and you can also find them on the Direfuse website. Our workshops are going to follow a plan of having an opening panel. The Mississippi panel, all of the panels will discuss anatomy of a disaster. We will introduce the consortium development that we are working on and have a breakout session where we discuss the convergent research that we would like to conduct and take input from all those in attendance. We will also be hosting some breakout sessions on diversity, equity, and culture of inclusion, and on education and workforce development. And we plan on having tutorial sessions in the afternoon of our workshops. The Mississippi one, I'm very much looking forward to seeing next week. So we'll have Rapid Institute having a tutorial on modular processes. And we will also have a tutorial on the water, energy, food nexus and how these facilitate systems analysis. Our updated website is there on the screen, tx.ag/direfuse. You can also scan the QR code to visit that website, that updated website. I'm sorry. You can also subscribe at the same website, Direfuse subscribe, to receive updates about future events and participation and so forth. And with that, I would like to introduce and turn things over to our speaker for today, Dr. Andrea Jackman, who's a senior consultant in data and risk sciences for the ABS group.
Thank you, Beth. Let me see if I can get my
We'll swap this
screen
over.
share going here. Okay, does that look good for the slides?
Yes, that's great.
Able to see that? Okay,
Yep.
Perfect. Sorry about that. I just got a new monitor and I feel like I'm still learning how everything works and what to do with the display. So first of all, thank you so much for having me today. I'm really excited for this opportunity because you'll see in a few minutes, I have some background with not only the state of Texas and emergency management in that area, but also National Science Foundation. I was pleased to see that this collaboration was ongoing for you guys to be able to host webinars, seminars, workshops, different things with a focus on some of these critical systems that we have to manage through disasters and through different events that maybe we're not expecting. So I'm excited to see that, and I appreciate the opportunity to talk today. I'll put my contact information at the end, but certainly, feel free to interrupt me at any time if you have questions. I was hoping if we could just use the chat feature really quickly. I'd like to see who all we have in the audience today. Just if you could post, are you a student? Are you a university professor? Are you a private sector partner? Just maybe say the organization that you're coming from or something like that, so that I can take a look. I guess I'm not going to be able to see it with screen share, but I'll try to pull up the chat here. There we go. Research staff, Texas A&M. All right, I'll come back to that later on. I'm going to assume that we have a variety of different partners and different participants today from a variety of backgrounds. Okay, let's see if I can move my slides forward. Okay, there we go. All right, so I just want to start by introducing myself. My name, again, is Andrea, last name Jackman. You can look me up on LinkedIn, or feel free to friend me or connect if something interests you from what I'm going to be talking about today. My background is actually in meteorology. I'm assuming that we have a lot of engineers on the call today, based on the sponsoring organizations, maybe some research scientists as well in the physical sciences of the different natural disasters that we might see. Maybe we have some man-made disaster scientists on here as well. But my background is meteorology and atmospheric science. I got my bachelor's from Valparaiso, and then I went to Texas Tech for my PhD in wind science and engineering. So I know A&M and Tech sometimes butt heads over football, and I understand. Yeah, I think Texas Tech sometimes confuses who their rivals are in football. Sometimes they think they're a little bit better than they actually are, but that's another story for another day. So, guns up, Recom Tech, all of that. I have a lot of Lubbock pride from my background. I didn't spend a whole lot of time in the Houston area, but we're going to be talking about it quite a bit today. So I'm used to when I think of Texas, I think of kind of the open prairies of the western half of the state. Not a lot of humidity out there like we have in Houston. I'm also excited to see that I was saying earlier that National Science Foundation is involved in these talks, because when I was at Texas Tech, I was under the NSF IGERT program, which at the time was specifically designed to have graduate researchers trained up in interdisciplinary and multidisciplinary research topics. So I was actually in the civil engineering department at Texas Tech. Even though you see my background was meteorology, I really didn't know anything about engineering when I entered the program. But the coursework was specifically structured by National Science Foundation to be multidisciplinary and to kind of fill in those gaps that some of us might have had. So I spent a lot of time with colleagues who were civil engineers in their background, or economists. And, I would have to bring them up to speed on meteorology and atmospheric science, and then they would return the favor. They would teach me about, wind loads on structures, terms that I had never heard before, but are sort of everyday occurrence for engineers. I had to get up to speed on that very quickly. So it was kind of a unique program in the sense that, wind engineering, people think, that must be like wind power and turbines, and that, there's a lot of wind farms out in West Texas. And that's true. We did have some people working on that, but for the most part, it was very focused on emergency management and hazard mitigation from a wind perspective, so that we were looking at, how can we build structures better to be more resilient to tornadoes, earthquakes, earthquakes wouldn't be wind, but hazard engineering in general, hurricanes and tornadoes, severe storms, the flooding that can come along with that as well. So after Texas Tech, I went to work at IBM. I was in the government services sector for over 10 years there, mostly working on FEMA projects. That having the background in emergency management, that was kind of a logical place for me to end up. I didn't always work in mitigation at FEMA. For a few years, I was on a response project with the focus on logistics. So working a lot with Army Corps of Engineers and other federal partners who help coordinate the logistical responses on the FEMA side, things like moving cases of bottled water or other critical commodities in and out of disaster impacted areas, figuring out ways to distribute those commodities to people who needed them. A lot of post Katrina emergency management reform. That was the PCHEMRA Act from 2006. FEMA received a lot of mandates from Congress to kind of change the way they did business following Katrina. So there was a lot of implementation of PCHEMRA policies at IBM. For the last 2 years, I've been with ABS Group, and not only are we based in Texas, but ABS has a wonderful history of collaborating with academic institutions for not only hiring. We like to hire academic engineers to work at ABS Group, but also in hazard sciences. We'll talk about that a little bit later, but nice history there. So I personally enjoy research and working with the academic community, even though I'm in private sector now. I like the process of exploring new topics through research, doing all the statistical analysis that comes along with that, and then going through the peer review process. I've had a couple publications recently that I'm especially proud of, with the United Nations Office of Disaster Risk and Reduction, and also Harvard Business Review. So check it out. I have everything on LinkedIn or ResearchGate. Feel free to Google my name, and those things will come up. Or if you want to get in touch with me, I'd be happy to talk more about that. I hope that in our conversation today, I'm going to wrap up with research questions, and I'm hoping that we can talk more in more detail about some of those topics. And if anything interests you, feel free to reach out to me. We can touch base. If you're looking for research topics and you think that there might be an opportunity, we could collaborate or have a conversation there. That would be awesome. So just let me know. Keep that in mind. I also wanted to introduce ABS Group, if you're not familiar with the company. So we are actually a subsidiary of the American Bureau of Shipping, which is an organization. It was a nonprofit going back even to the 1800s. There's a long history there of this, what was formerly a nonprofit government group that managed a lot of marine and offshore applications, not only shipping, but a lot of safety and process implementation for offshore and maritime applications as well. So the ABS Group, though, is the sort of the consulting certain services provider within ABS. We are a for-profit company that is a part of that, based in the Houston area. I've actually never been down there because I was hired during COVID, and we couldn't travel. But we do have a history of hiring from Texas universities. When I was at Texas Tech, two of my colleagues were hired by ABS right after graduation. One specialized in wind engineering, and the other went to the earthquake division within ABS, which is now a separate company. But it's beside the point. we have a history of hiring engineers and working closely with the academic community for that. So what we do for the most part now is services consulting. And you see we're in over 20 countries. And I actually noticed that Poland is not filled in. That was my boss recently did some work over there. In fact, he was stranded there for a little bit during COVID. He couldn't get back to the United States. So we should have, that should say 21 plus countries. We should have shading over there. But that, that's what we do now. And we still have a little bit of a maritime focus. We do work for the Coast Guard now in the government sector through ABS Group. But for the most part, we're not limited to marine applications in ABS Group. We do a lot of on land safety work as well. See if I can move this with the keyboard. There we go. Okay. So I'm not going to read through all these bullet points, but this is just to continue to provide a little more detail on what ABS does. I would say probably our biggest focus area is safety, specifically risk analysis and compliance management. So we take a lot of federal guidelines, mandates, et cetera, policy that's available, whether it's through FEMA for emergency management or, just in general, anything with process safety or risk management in the workplace, accident reduction, natural hazards mitigation, things like that. That's probably our main business area focus. You see on the left-hand side there under safety and risk compliance. But we do other things too. We're starting to explore more in the direction of IT management and software development, because that seems to be the direction that a lot of these federal agencies want to go. They, not only do they have the background for providing policy for different functional areas, but now they want to, federal agencies want to provide IT support for that too. And you'll see I'm going to speak about some FEMA programs that we've developed recently that do exactly that. They provide kind of the online / digital support for different policies and practices that FEMA would like to see implemented, or that the federal government would like to see implemented. We also do a lot of training, which is nice, that sometimes with safety training is usually a top priority, but also within the emergency management realm, we've created a lot of YouTube videos for FEMA that sort of train up users on different things, kind of to replace the EMI. I don't know if any of you are familiar with the Emergency Management Institute, but we're FEMA, especially with COVID, FEMA wants to get away from classroom instruction and the in-person environment. They want to just make things freely available. YouTube is usually the best way to do that, to just post a video on there. And so a lot of the training in recent years, at least for FEMA, has shifted to that environment, and ABS has provided a number of products there. We also, as I mentioned earlier, we have a history of providing engineering services. So that bullet that you see in the top right there, extreme loads and structural risk, we're looking for, PEs and PhDs in that area who can provide engineering services and analysis when needed. So specifically, this is just to, again, give some more background on the private sector aspect here. We try to use that highly technical engineering background and apply that to the different government agencies that we're contracted to. So I'm going to walk through some case studies here in a little bit, but we do a lot with water systems management, so dams and levees, engineering for extreme hazards, the impacts to those components of critical infrastructure. So, if we have an earthquake, what does that mean for the for a bridge system, water reclamation, dams and levees, that stuff like that. I mentioned training already, so I'm not going to talk too much about the YouTube there. But we also, kind of along the lines of hazard engineering. I don't know if any of you are familiar with the company Equicat, but we used to be part of ABS, and they did a lot of earthquake engineering. They now belong to CoreLogic. So we're partners, strategic partners with the same groups of people with CoreLogic, who are with Equicat. But that's just another example of the kind of stuff that we work on. I mentioned U.S. Coast Guard. We do a lot of process consulting for them. The bullets on the previous slide, those are the types of activities we do for Coast Guard. A lot of safety and compliance, a lot of risk analysis, a lot of creating products that Coast Guard users may need to see from a public facing standpoint, but ultimately Coast Guard is managing the back end of that. So they need IT system support. Same for DHS and FEMA. And then, we don't just work with federal government, we also work with state and local. In fact, the first case study that I give is going to be for the city of New Orleans. So we'll see that here shortly. There we go. I have my slide. All right, so I'm gonna give 3 case studies, and this is gonna be the first one here, which is work that we did for the city of New Orleans. Back in August of 2017, they had an unusual rain event, and I know we might have some folks on the call today who are in the area, may remember this, but there was between 8 to 10 inches of rain that fell in a single day over parts of the city. Different gauges recorded somewhere in that range, which is a lot of rain, understandably. And of course, New Orleans has a system of pumps that is designed to handle this influx of water. But they didn't work. Not all of they didn't work completely. There were power outages caused by the rainfall, and that had an impact. There was a lot of inconsistency across the city as far as how the different systems were performing. Some pumps were fine. They did their job. Other pumps, they were working, but it was kind of at a reduced capacity. They weren't pumping as much water as they were planned to or expected to, or maybe designed for. Some of the pumps were completely non-operational. They went totally offline, either due to failure, mechanical failure within the pump itself, or power outages to the systems that were responsible for those particular sites. And then some pumps were working, but they were pumping in the wrong direction. So they were actually adding to the flood water. They were making the situation worse by instead of taking the water out of the area where it was supposed to be removed from, they were adding more water back in. So the city said, okay, what's going on here? We need to do some kind of audit or some kind of investigation. In emergency management, we talk all the time about after action reports, hot washes, whatever you want to call them, where we try and dissect if we had something during a response that didn't quite go as smoothly as expected, we want to get in there and figure out what it was. On top of all that, the Sewer and Water Board for the city of New Orleans, their real-time reporting, it wasn't always entirely accurate, and it gave the impression that they maybe weren't on top of the situation with what some of the pump failures, what might have been going on in real time. They were at one point incorrectly reported that all the pumps in the city were operating in full capacity, and that clearly wasn't the case. So the city, first of all, they wanted to figure out what actually happened during the event with the pumps. Was it a mechanical failure? What is it due to power outages? What was causing the reverse flow of the reduced capacity, the completely broken down pumps? But they also wanted to find out, what was the communication like at the Sewer and Water Board? Why did they seem to be reporting incorrect information? Was there a misunderstanding or a miscommunication? What was going on there? So ABS was hired to perform this analysis, to do what's called a root cause analysis and figure out what the root causes were for the failure of some of these systems. And we want to find the root cause, also the causal factors. So if there were interactions with other factors, interactions with things like the power system, what might have caused that to fail, and how that could have had trickle down effects into the pumping system, and what could have happened there. So we did that. We went in and there conducted interviews, performed evaluation, like mechanical evaluations on the different pumping sites, and looked at the process for the ongoing maintenance of those systems, how the Sewer and Water Board was staffed in relation to maintaining those pumps, if they maintained an emergency operations center, and how they structured that, how they what the process and procedure that they followed for public notification, and coordinating the different players. Obviously there's a couple different agencies involved. It's not just Sewer and Water Board. So we wanted to look at that, interview the different stakeholders, find out what, if any, role City Council would have played in some of these communications and some of these processes. I have a little spoiler alert on the slide. As so often with big systems, there were multiple points of failure that led to the flooding and the damage that was caused by it. Certainly there were mechanical failures within the pumps, but also there were other just systemic failures, the things that you typically see in situations like this. Communication breakdown, miscommunication, failure to plan ahead, I guess, mismanagement of different things that might have popped up during the event that were not anticipated. So I have a little timeline here that we don't have to get into the details of what happened, but certainly the power outages contributed, and certainly the communications and existing processes didn't help either. So after more than 30 interviews with different stakeholders across the different departments in the city, we came up with our root cause analysis. It was ultimately presented to not only the City Council, but it was created or added to a public forum so that residents of the city could view the report and hear the results. And the feedback was very positive. Overall, even though it feels like we're kind of pointing out failure points and maybe where some mistakes were made, when you can show that it's a systemic, the root causes are systemic for a complicated system like a series of pumps for a major metropolitan area. It doesn't feel as much like finger pointing. It just says, this is a systems design issue fundamentally. And if we want to make sure this doesn't happen again, we need to design our system differently so that people feel comfortable acting within that system. And, we're anticipating some of the things that might go wrong, and we have mitigation in place and a process in place to anticipate some of that uncertainty in the future. So it was very well received, and hopefully just much like Katrina, there are lessons to be learned, and hopefully those will be implemented. I think anybody who remembers the situation in New Orleans after Katrina, I think we've seen incredible positive improvement since then. The lessons learned were really taken to heart, and I think Louisiana in particular has just continued to improve as the years have gone on with emergency management. So I think that pattern is certainly going to continue. So that's something that's a city level example. Now I'm going to move on to a little more broad regional example for county and state level government. Another analysis that we did through ABS Group was work with something called the substantial damage estimator, which is a FEMA product. I'll go ahead and move my slides forward. It started the ABS involvement, started with flooding in Baton Rouge in 2016. And then I think that was where FEMA said, you know what, we could use a little bit of help with the substantial damage estimator. And I'll explain what that is here in a few slides. But again, to kind of set the stage for this case study, I think if any of you on the call here from the Houston area, you probably remember Harvey from 2017. It actually made 2 landfalls in Texas. There were 5 total with the storm track. But two came in Texas, kind of in the I guess Port Aransas and Nueces County, a little bit further south of Houston, there along the coast. But then the storm stalled out. It was originally a Cat 4, and then it made a landfall and weakened to a Cat 3 hurricane, and then it rapidly. Usually, once hurricanes cross over land, they fall apart pretty quickly. Harvey just sort of turned into a tropical storm, but what was unusual about it is it sat right over Houston for days and days, and just rained and rained and rained. In fact, I think there I have on the third bullet down, Cedar Bayou received 51.88 inches of rain for the entire storm, which is over 4 feet of rain. And I mean, that's unheard of. It's obviously not only a U.S. record, but all of North America. Harvey set the record for that rainfall. I mean, I'm only 5'1", so to get 4 feet of rain, it's almost unfathomable to me how this would tax the system that's meant to deal with floodwaters. I can only imagine. So that was just a little bit of background on Harvey, but from the FEMA perspective and from the flood management perspective on the FEMA side, the first thing that they try to do is establish substantial damage estimators. And this is meant to be sort of a rapid post-disaster deployment of local officials who are familiar with, it could be floodplain managers, CFMs, or local officials who have familiarity with the local building codes, and they can determine where substantial damage has occurred in a given area. So FEMA has a tool for this, the substantial damage estimator, and the idea is that you deploy these teams of local officials who have this knowledge, specifically to try to determine how many structures are more than damaged to more than 50% of their pre-disaster market value. Which sounds good on paper, I guess, but in practice, it's very, very difficult to do this because, I mean, first of all, according to the National Flood Insurance Policy Program, according to that policy, FEMA recommends that you start with local level officials. Well, I'm going to go back on my slide. If your street looks like the one in this photograph, your local officials are probably busy with other things in the immediate aftermath of something like this. So to put this requirement on their shoulders is asking a lot. And I think FEMA started to realize that after a few different years of a few different events where they wanted to implement this program. And so they bring in contractors like us, like ABS and other groups, to first of all, to help to say, okay, let's get more boots on the ground, as they like to say, people who can go out and conduct these estimates and use the tool. But also to ask, is there a better way of doing this? Like, do we really need to have somebody walking around, or you know, maybe in a boat going around to different structures with a clipboard saying, yes, you know, this location is more damage to more than 50% of its market value according to the measurement indicators in the tool. It's very difficult. If you'd like to know more about this program, the tool is freely available on FEMA.gov. You can look into the details more if you're interested, but I think, actually, we'll come back to this later. I think SDE might be an interesting area for future research to see what can be done to sort of improve the process and get information more quickly. So when initially I was mentioning the Baton Rouge implementation that FEMA did with SDE, I think originally in Baton Rouge there were over 60,000 inspections that were completed for the SDE program. And you know, when Harvey hit, they knew it was going to be a lot more than 60,000, and they started to say, what can we do differently to make this go a little bit smoother? So APS came in, and we actually used some machine learning techniques it was a little bit experimental to see how this would work. So we created this RADAT tool to take building data, input building data that can be obtained before the flood happens, have the data ready to go, and then use both AI and machine learning processes to figure out, you know, instead of having to do manual inspections for SDE, just get a blanket estimate of where the damage is low, you know, where the damage is concentrated, where the substantial damage is concentrated within that, and estimate cost and dollar losses. So the first step in our process, we did automated clustering, which is to separate the buildings into categories. We want to keep, obviously residential structures would be measured separately from large commercial buildings. In the downtown area, you're going to have skyscrapers that have different construction, obviously, than something like a wood frame residential home. So you want to start by separating these out. You can also look at quality of construction. In the United States, we have pretty good building codes that, for the most part, are adhered to. But this is not the case. I'll share. The next slide here is going to talk about Maria. In the Caribbean, this isn't always the case. They have different building practices from us, on the mainland, and different code practices, different building code adherence enforcement, and this can lead to a couple different building types that are geographically dependent. You see differences across regions, and you want to be prepared for that if you're going to do some kind of analysis like SDE. You want to take into account local code conditions for buildings. So setting up an automated clustering system like this is the first place to start, and we'll see a process like this with one of the other programs that I'm going to describe as well. So then, based on the different clusters that we create, we can then perform different analysis on the building types to say, well, if depending on the depth of the flood water and the location of the building, we can use GIS to say, all right, I'm going to put my building here, and I know that at this location I had, let's say, 4 feet of water, since if that was the one example I gave. And I know I have a damage function for this type of building, where I can say 4 feet of water is going to result in, let's say, if it's a 1-story wood frame residential structure, then 4 feet of water is going to result in 90% damage. Let's say you think of that image I had on the previous slide, where the water level is right up under the eave height on the roof, that that's probably going to be a structure that's mostly destroyed. Certainly the contents and if you have any contents and inventory on the inside of the building, it's going to be almost completely wiped out by 4 feet of flood water. If you compare that to, let's say, an office building, maybe that has reinforced concrete, reinforced masonry structure, it's 4 or 5 stories, or a parking garage or something like that. 4 feet of flood, it may not be a big deal. Or if you have even a wood frame residential home on stilts, on a stilt foundation, 4 feet of water may not be a huge damage indicator. And so you refer to the damage, you refer to the damage function for that to say, okay, for my concrete structure here, my parking garage, I have 4 feet of water, but that only results in 10% damage. And so assigning, using these damage function indicators, using methodology that's been vetted already for SDE estimations, you can start to create a map of the area and say, okay, yeah, now I can see my hot spots, that maybe in one part of the county, where it's mostly 1-story buildings or residential construction, that's going to have the most damage from 4 feet of water, whereas other part, maybe if you're in a commercial district, the damage isn't quite as bad. So again, this was a successful project by ABS. It actually won the FEMA Administrators Award for Innovation the following year after Harvey in 2018. So we're proud of that methodology and proud of that application. We got to test it and expand a little bit with Hurricane Maria data, because the same process had to take place with SDE in Puerto Rico. And as I was describing earlier, we make certain assumptions about construction techniques and construction practices when looking at flood damage. We can make certain assumptions about that in the mainland US because of building codes that we have validated, and even census data contains building attributes that can be useful for this type of analysis. In the Caribbean islands, that's not always the case. The Caribbean territories, Virgin Islands was also hit by Maria. I think Irma was the other storm that impacted Virgin Islands, but the building practices are a little bit different. And we can't make the same set of baseline assumptions about building code practices that we do for the mainland US. We have to adjust that. Just, for example, residential construction in the territories, whereas in the US, we might see a wood frame 1-story is pretty typical for residential. There's a lot of masonry, unreinforced masonry construction. So concrete bricks and metal roofing is a lot more common in the island territories. And these behave differently, especially in wind conditions that might come along with the flooding from hurricane. So all that to say, we partnered with another company for Maria to do a similar approach for the SDE following those storms in the Caribbean. And there was a little more expansion this time. We were able to do not just structures, but we were able to look at some of the, the power grid, water supply systems, transportation networks in the Caribbean territories that were impacted by these storms. So it was a good project. We worked with Atkins on this, and again, showing a lot of promise for the SDE process over at FEMA. All right, so I'm gonna take a little break here. I can't see the chat. I can see that it's blinking, so I'm gonna trust our moderators. If there's something urgent that comes up, somebody wants to interrupt with a question, feel free. But I can only see like a little, a little red dot on the chat menu popping up. So I'll continue here. I want to wrap up here so that we have time for discussion of research questions. Another program that we work with a lot at ABS is the FEMA Risk Map program, which is Risk Map is just an umbrella term for a host of flood mitigation programs that are available under FIMA, the Federal Insurance and Mitigation Administration, which is a division of FEMA. You've probably heard of the National Flood Insurance Program and the National Flood Hazard Layer. These are both risk map products. All that means basically is if you want to buy a house or you're looking at any kind of property development, it's a good idea to check the NFIP policy and check the NFHL for that geographic location. It's all of it. FEMA has all kinds of websites you can go in. The NFHL one is especially nice. It's a GIS engine. So you just go in, you enter your address, you say, I live at, 123 Main Street in Houston. I want to buy a house here. I'm looking at it. You enter the address into the FEMA site and it'll tell you where you sit within the National Flood Hazard Layer. So what everybody wants to know, that like the number one question is, am I required to have flood insurance for this property that I'm entering? You can get those questions answered. But there's different levels of floodplain and different classifications depending on where you are and how close you are to a body of water. So it's interesting. If you've never had a chance to tinker around with it, I recommend going on there. You can check your own house. I always joke, I live in Pittsburgh, where we have, I think we have more bridges than any city in the world. Even Venice, we outnumber them for bridges, which I don't know how that's possible, but we have flood insurance is a topic of conversation around here a lot because we have a lot of rivers and streams that impact different properties. But we also have a lot of hills, and I live on top of one, so I'm always kind of appreciative of that whenever we get into a flood insurance conversation. So anyway, that's just an example of one of the many risk map products that ABS has worked on or that are available to the public. They have a really nice benefit cost tool. They have a whole suite of mitigation products. If you're a state or local mitigation planner for flood damage, FEMA will come out with these sort of broad policies. Flood insurance is a good example, but they'll say like, oh, to get such and such a grant, you will need to conduct your mitigation, to demonstrate that you've done mitigation for the hazards that you're vulnerable for. In your specific area, and they provide a lot of tools to do that. Benefit cost is a great one that'll help you measure the economic impacts of different mitigation projects. You can also track other mitigation programs that if you're receiving grant money to do mitigation for something, you can track those programs. You can track the planning process of submitting a mitigation plan through there. There's the MAP Service Center, which is like an IT portal for downloading different products and tools and data, all falling under the risk map umbrella. So that I won't dwell too long on this. It's just a high level summary of the types of things that ABS has helped with over the years as far as maintaining different products. So the last case study I want to present is not an event per se. It's talking about the HAZUS tool, and hopefully most of the people that have joined today are familiar with HAZUS or you've seen it before. But ABS has a great legacy with HAZUS. We were the original designers of the flood model, and for many, many years, it was a great one before HEC-RAS and before ArcGIS had become as widespread as it is now. HAZUS was a way that you could generate a depth grid free of charge. FEMA doesn't charge anything. They make the software available. They used to ship it out on DVDs. Now you can just download it off of FEMA.gov. But for many years, this was a great way to generate a depth grid for flood within GIS, and you could apply that depth grid to your geographic area and get a feel for some of those damage functions that I was explaining in the Harvey scenario. So you can say, all right, I had this much rainfall and I had such and such inundation from hurricane surge. tell me how deep my water is going to be at a given location. And then if I have a building there, I'll tell you what type of building, and HAZUS will tell me how much damage I can expect. If it's a foot of water, maybe it's 50% damage. If it's 4 feet of water, maybe it's more than that. So it's a really interesting product. It runs like an ArcGIS plugin. That's a simple way to say it in software terms. And if you have an ArcGIS license, if you have anything for any of the desktop products, so like ArcMap or ArcCatalog for desktop, you can download HAZUS and start running it tomorrow and kind of tinker with the different settings and get a feel for just some of the scenarios that you might encounter. It's not just for flood, there's also earthquake, tsunami, and hurricane that are available. Tsunami and hurricane do use a component of the flood model. Tsunami obviously would be a combination with the earthquake for that. And then hurricane is a combination with the wind model to do surge. So the two main things that the two main outputs from HAZUS are physical damage and economic loss. That's what we're hoping to estimate with the software package. And it's specifically marketed to state and local mitigation planners who need to see the potential scenarios, the risk that they might face for different flood scenarios. But then also we have a pretty big academic audience using HAZUS for research. The last estimation, I think, for the user community was over 10,000 users globally. So FEMA's very proud of the HAZUS product. And I'll talk about some of the improvements that they're hoping to make, because it is starting to get a little bit dated in terms of technology and methodology. But ABS has a long history with HAZUS. We were the original designers for HAZUS Flood. Long ago, it didn't belong to FEMA, it belonged to the National Institute of Building Sciences. Although that was later transitioned in the early 2000s, FEMA took over ownership of the software and the code and everything. So it started out as an earthquake model, but obviously now we've expanded to 4 hazards, and there's some integration there between those two. We also contributed to the kind of an offshoot of flood. We combined that with the wind model that was built by a company called ARA. And now we have a combined surge model that actually uses not only ARA code for wind and our code for flood, but we also bring in the Slosh and Swan models from NOAA. If you're familiar with those, they model storm surge in different ways. So it's kind of a three-way collaboration way that we're working with right now and HAZUS surge. So we want to continue to grow this. FEMA is certainly on board. We've gone through several major modernization efforts and re-architecture efforts on the software development side. I think the next big push for HAZUS is going to be open source. That seems to be the direction that not only FEMA, a lot of federal government is looking to go more open and looking at what they can do with Python, so that in the past, if somebody maybe disagreed with the output from HAZUS, there would be a whole process of, getting in touch with FEMA and saying, oh, I disagree with how you estimated these losses. I think it's going to be this, whereas your model says that. Can I see the code, or can I see the methodology that you're using? And we did our best to make that transparent, but there's no substitute for being able to hand somebody an open source code module and say, yeah, this is how it's calculated. And I think that for the most part, it seems to, the federal government in general is moving in that direction to more open. So I think that's probably where it's going to go in the future. Specifically, I know the goal of these webinars is to talk about emergency management applications for water, energy, and food systems. And HAZUS is probably the best option, the best product that FEMA has to offer for those 3 specific areas. And the reason is that, not only do we have a lot of that data already in the model, but we have the code is designed to encourage users to bring in their own data for those particular systems. So built into the model already, we have anything publicly available from Census or, oh, now I'm not going to be able to remember the acronym for the critical infrastructure data. HZip Gold was one of them. And there's another one too that I'm just drawing a blank right now. But the point is we pull in publicly available critical infrastructure data and package that with the model so that it's already waiting there, ready to go. We have not only the different types of construction that I mentioned earlier, we have buildings classified by, are they wood frame? Are they steel frame? Are they pole barns? Are they masonry, unreinforced or reinforced masonry? Are they, how many stories are they? What's the foundation type for flooding? What's the roof type and roof connection type for wind? We have all of that data already packaged in there. And then we have the blank databases if you want to update our data or you want to bring in your own, because obviously we pull from what's publicly available, but nobody knows better than locals to the specific area, what type of buildings they have or what might have been newly built recently. So we have all the building type. We also have for the critical infrastructure, we have power grid components. We have pipeline. If you have a pipeline distribution system, we have, I think, potable water, wastewater, sewage treatment facilities, the different levels of substation facility for electric power grid. All of this stuff is built in, or if you want to customize it or you want to do that, or you want to bring in new facilities, you can do that as well. So that's probably, even though we're proud of the fact that HAZUS has very good vetted methodology and it's been around for so long that it's been proven and established and it has credibility. We also love the flexibility that it provides for you to bring in your own structural components to analyze. And again, we're looking, the output, the goal of HAZUS output is to estimate physical damage and economic loss. So if you do bring in your own data for those facilities, those are the kind of results that HAZUS can provide for you. You can determine what's my level of physical damage, either due to floods or whatever hazard you want to look at, but also that economic loss, which the economic component I'm going to talk about here at the end for research questions, because I think dollars are always where people are most interested in research findings. So I think I talked about this already. I won't spend too much time. We're trying to get more, this is just kind of an example of the type of work that ABS is doing right now for FEMA. We're trying to get HAZUS to be more open, more user-friendly. The old way of doing things with the GIS software that we provided that I showed before, the old way of doing things was to, you have to learn how to use GIS first of all, which is no small task. You have to learn something about hazard engineering, the physical hazard itself. You have to learn about this to understand, okay, when I have a hurricane making landfall, this is the way the wind is going to impact my structures. This is the way the storm is structured itself, the way that I can expect the wind directions to be and the wind speeds, depending on the different storm parameters. You have to have an understanding of that. And then you also have to have an understanding of engineering to say, yeah, if I have a building that gets inundated with 3 feet of water, what does that mean for my structure? It helps to have that background too. We're trying to, by going open source, we're also trying to post results online. So the HAZUS Loss Library, you can check this out right now on hazards.fema.gov. We have a number of scenarios where we've already run analysis for you. You can go onto that URL, download, if you want a PDF or you want a CSV to put into Excel, or you want a shapefile to work within GIS. You can download some of these preset scenarios and not have to worry about obtaining all the training in the background, the information. You'll just have the results packaged for you there. And then we're also looking at modularizing some of that has its functionality to an open source environment. So FAST, this flood assessment structure tool, has been kind of the pilot for that movement to open source. This is a Python-based module that you can download also on the MSC.gov website. We used to have it on GitHub, so I had to stop and make sure I had the right link there. But you can do you can do really nice visualizations with this. This is just a way to, again, not have to go through that cumbersome process of installing ArcGIS on your work machine, not having to pay for the license for ArcGIS, none of that. You can just use this Python module, bring in your buildings, bring in your flood depth grid, run them through the module, and get HAZUS results outputted that way. So I think there's more of this to come in the future. We're just getting started with that. So just to wrap up here, I see that we're at 12 o'clock Eastern, and I know that we have about 30 minutes left. So I want to leave this open for discussion. What are the kind of research questions that we're faced with in implementing programs like the ones that I've just described? And this is where I tend to get a little bit enthusiastic, a little maybe over enthusiastic about, what can we look at for the future of research in this area? What kind of collaborations would be beneficial, not only for us with ABS, but our clients and our customers that are asking these problems. They're coming to us because they have these questions. What can we do to support them from a research side? And the first one, I think, is probably the obvious question that everybody asks when something like this happens, which is, how can we prevent this catastrophe from happening again? How did we let this happen in the first place, and how can we prevent it in the future? So just a simple question of mitigation, and we can apply that to water, food, and energy systems. Are we doing everything we can to mitigate catastrophe? Is there more that we can do? How, what type of mitigation projects would be best for presenting future catastrophe? I think that one's probably the one that we're all thinking to begin with, so I'm not going to spend too much time on it. The second thing, though, that I think there's not as much time spent, but really has a good impact, a profound impact when you put it in terms of economics, and that's cost. Very few people, I think, ask, what are the costs associated with mitigation? And I don't just mean, everybody asks, oh, I want to retrofit a structure. What's that going to cost? That's not the kind of thing I'm talking about. I'm talking about the process that surrounds that. So like writing a mitigation plan, if you're a city or a county, what's the cost associated with that? What's the benefit cost ratio for that? Taking a mitigative mindset or approach to different activities. I think a lot of people don't factor in, from an economic perspective, something called opportunity cost, where you're asking, if I don't retrofit this structure, what will my losses be without that retrofit? Because that's a cost as well. If you're going to spend $5 million cleaning up from something where you could only spend $1 million plus mitigation costs, what's the difference there? So BCA kind of gets into this, the benefit cost tool that I mentioned earlier. It's a really good product that FEMA makes available, again, free of charge. You can go and download it, and that'll help answer some of these questions. But I think it's a perspective that we don't often talk. Opportunity cost is in particular is something that we don't often talk about, and I think there's some really interesting potential for research there within specific systems. Okay, this is exactly what I was just saying. If we take that economic perspective and apply it directly to some of the specific systems that you look at in these programs, water distribution, water management, food distribution and management of those systems. I think the economic perspective, we can benefit a lot from applying an economic perspective, to say, yeah, we're not putting our dollars in the best place. There's better places we could be spending money in preparation for some of these events. And in some cases, true mitigation, I feel, if you're able to target the right areas, you can sometimes prevent a disaster from happening at all. Floodplain reclamation is a great example of this. If you purchase structures out of a floodplain and move them, restore that land to something that wouldn't be as severely damaged in an event, maybe it's a restored to a natural habitat area, or maybe within city limits, you convert it to park space, something that can be allowed to flood naturally. And now you're not you're not causing yourself any dollar losses. Now you've eliminated an entire disaster. Being in the shipping industry, I also like to give the example of double hull ship design, which is something that came about after the Exxon Valdez oil spill many years ago. A lot of ships were built with a single hull, so it was just a piece of metal that separated the boat from the inside of the boat from the water around it. Well, after the oil spill, and actually after some of the terrorist attacks from like September 11th, and when some of the emergency management focus was placed on man-made events and explosive events and attacks. The shipping industry got together and said, hey, wait a minute, if we just build a double hull, put an extra layer of metal in there on the inside of the ship, suddenly now that, like Exxon Valdez, that it wouldn't have been nearly as catastrophic as it was. Or, if we have an attack with explosives, it's going to be even more difficult to cause damage. If we're looking at somebody who might attack a port from a terrorist point of view, or the shipping channels. Now we've eliminated that disaster entirely because we've designed our ships differently. So I think that, to me, that's true mitigation, is asking ourselves, what can we change in our current process that would eliminate the disaster, eliminate the risk altogether? And then we can turn our attention to things that we can't necessarily predict, and there's more uncertainty there. Another thing I think it's useful to look at is correlations between what we're spending and the results that come out of that. There's really interesting work being done with GIS, where they look at vulnerability indices, and I'm seeing it now with resilience coming up too, where you can take a bunch of spatial layers, layers of data from a mapping standpoint, overlay them with each other, and then you can start to identify hotspots, kind of like we did in with the New Orleans pumping stations. You can identify hotspots where there may be more vulnerability, or there may be less resilience is not quite as strong as what we want to see in certain areas. You can measure all this with GIS, and then you can start to look for correlations to say, what are the areas that we should be targeting for better, what are the geographic areas that we should be targeting for improved mitigation, or where do we expect our dollar losses to be the worst within the city limits, for example. I like to reference some research that a student of mine did a couple of years ago, where she asked a very simple question looking at FEMA mitigation grant data. And she said, what if we see an area spending money pre-disaster on mitigation, does that result in less response dollars being spent in that same area? So if we're mitigating, is there a negative correlation with response dollars? And what she found was that actually they're positively correlated, which is the opposite of what we would expect or hope to see. Positive correlation means that the more you're spending on pre-mitigation, the more you're spending post-disaster, which is a little bit counterintuitive. I still, obviously, seems like every research study, the answer is, well, more research is needed. But, I guess my personal hypothesis about that situation is that if you're good at getting grant money, you're good at getting money across the board. And what that means is if you're good at getting mitigation, you're good at writing mitigation grants and bringing in that money to spend on, pre-disaster retrofitting or whatever it is. If you're good at that, you're also going to be good at writing the grant or making the case post-disaster that you need more funding to support. So, these are, to me, really interesting economic questions that I think certainly would apply to the types of systems that we're talking about. And then finally, this is my last slide. If there's engineers in listening in today, there's like, we're all in the family of engineering, but there's a cousin that we never talk about, and that's industrial engineering. At least we never talk about like the civil and mechanical side, the types of people that are designing like flood control systems and pumps and everything. I think very rarely cross over with industrial engineering. And actually that the industrial branch has tremendous toolkits that I think would benefit emergency management so much. And we're not to the point where we're talking about them yet from an emergency management perspective. Statistical process control is a great example. If we had applied statistical process control to the city of New Orleans case study that I mentioned, somebody might have hit an alarm that said, hey, wait, this pump is out of control, right? It's, and I'm using out of control in a statistical sense. We have quantitative bounds on what the performance of this one pump is supposed to be. And we can see that it's overwhelmed, like statistically, there's too much water and it's not going to be able to do its job. So, there's all kinds of things out there, quality measures, management science. These are, I just have examples up here of like broad areas from within industrial engineering. Ergonomics is another one. Are we building our emergency management response systems and tools to best answer the need that is out there? I think all of these are questions on the research frontier that maybe we really haven't started talking about yet. And I'm hoping that soon, we can get some research going in these areas, and it'll be interesting what we find. So with that, I think we have about 15 minutes left, maybe for questions and conversations. So I'm going to wrap up here with my presentation, and I thank you very much for listening.
Fantastic. And we thank you, Andrea. Anybody in the chat or would like to unmute and ask a question, feel free. I don't see any popping up in the chat at the moment. We'll give everybody just a few minutes. Here we go. Carol Goldsmith asked, I would like to hear more about how risk and equity measures are incorporated into the SDE estimator and then used in decision making.
Sure, that's a great question. I think as far as used in decision making, I don't have a good answer for that just yet, because my understanding of the SDE estimator and the SDE program in general is that it's still somewhat new. We're only just seeing the implementations within the last 5 years coming out of some of these major storms. And I think risk and equity are kind of naturally sewn into that fabric of substantial damage. I think, in areas of higher risk and in areas of less equity, you're more likely to see substantial damage. And so right away, that's like a preliminary indicator of some place that we might think to look. And, that's built into the modeling products that we developed. to say, we have economic data from the census, we have structural data from wherever, to say, the houses in this area are worth more, houses in this area are worth less. There's financial inequity maybe between some of these areas from a structure standpoint that we can use as a starting point to say, all right, we're kind of hypothesizing that we're less likely to see substantial damage in the areas with maybe higher home values, or where there's been more financial investment. So it's a broad terminology, and I think I feel like it's only been a sort of a new or recent push within FEMA to kind of incorporate some of these the equity component into the risk analysis. So I don't want to speculate too much, if that makes sense. I think we're going to see it more and more, especially from a financial standpoint, of building the models with the underlying assumptions that, okay, we want to reduce inequity, we want to reduce risk. We need to start identifying the places where those values are the highest. I hope that is at least somewhat of an answer to your question.
Anyone else? We have questions. You can enter your question into the chat or in the Q&A module, or you can ask. Feel free to ask as well. Andrea, I just wanted to thank you for joining us and doing this webinar for us. This has been fascinating stuff. It has given me several ideas for things that we can do in our research lines as well. So I really do appreciate this very much. Any questions, any more commentary, any discussion to come up from the participants? Okay, seeing none, I'll remind everybody that our workshops are still available. Our in-person workshops in Mississippi, Texas, and Louisiana. We still have plenty of room for folks to attend. We would love to have you all there. Please share. If you can't make one of them, please share with colleagues that you think might be interested. We would love to have input from as many resources as we can as we work toward building this convergent research line. And with that, if there's no other questions, we'll wrap things up for today. I don't see any questions popping up. So Andrea, thank you again.
Thank you. Thank you for having me. It was a pleasure.
Thank you. And we'll wrap today's webinar up, and we will look forward to seeing everybody at the next one.